Okay, so how do we actually find the first and second derivative and so on, right? So if I have a basic polynomial function here, so we know how to find the first derivative, right? So we're just going to apply our basic power rules. So I have 6x to the fifth minus 8x to the third plus 10x. Okay, minus 3. So notice that 9, the derivative of 9 as a constant is 0, right? So let's say I wanted to take that a step further. Let's say I wanted to then take the second derivative. So the good news is that you would do the same exact thing as you just did, right? So we're going to, again, just keep basically applying the power rules. So 6 times 5. So I have 30 x to the fourth minus 24x. Okay, plus 10. So then again, notice this guy is going to drop off because the derivative of negative 3 against a constant is going to be 0. Okay, and then again, if I wanted to take the fourth or the third derivative, right? So I'm just going to keep going with it, right? So 30 times 4 is 120 x to the third minus 24. Okay, and then again, the plus 10 drops off because it's going to be a constant. And so then if I wanted to take the fourth derivative, again, notice I'm going to write the little 4, okay, of x is equal to, so I have 120 times 3 is 360 x squared, and that's pretty much just going to be it, right? Because the derivative of negative 24 is 0. Okay, so every time we take a derivative, we're just going to go ahead and apply the same derivative rules that you would as if it was the first derivative. Okay, now the question is, what do we do in a little bit more of a complicated case like your next example? Okay, so if I have something like this, okay, I'm still going to take the derivative as I would, right? So dy dx, and again, I'm just going to write different notation so you guys can kind of get used to it. So remember, that's really x to the 1/2. Okay, so basic power rule, I would do 1/2 x to the negative 1/2. Okay, and then here I would go ahead and bring that 2 down, so it's going to be plus 2 x, again, I'm going to subtract 1, so x to the negative 3. Now, normally here you would stop, right, and you would bring your stuff in the denominator if it had a negative exponent. But guys, if you know that you have to take a second derivative, there's no reason to bring it in the denominator and then bring it back into the numerator. So I'm just going to leave it like this because I know that it's easier for me to just simplify it all at the end. Okay, so again, I'm going to go ahead and bring this down. So I have negative 1/2 times 1/2 is negative 1/4. Okay, x, negative 1/2 minus 1 is negative 3/2. And then I have negative 3 times 2 is negative 6, x to the negative 4th. Okay, and now I can go ahead and simplify it. So I have my second derivative is going to be, okay, I'm going to go ahead and bring that down. So I have negative 1/4, and you can write x to the 3/2, or remember that's just cubed root of x squared, okay, minus 6/4th root of x. So again, you don't want to simplify it. If you know you're going to have to take more than one derivative if they want the second or the third, don't simplify your negatives. Don't do any of that. Just leave it alone in the first derivative and then keep going, and you can simplify in the end.